Hi, this is Chris Kiefer, and welcome to the Power of ERDC podcast. Today, we're talking about ERDC's Global Forest Modeling Toolkit, which supports the Warfighter with mission-critical intelligence about vegetation around the world. Joining us to talk more about the model is Dr. Nathan Beane, a senior research forester at ERDC's Environmental Laboratory and lead of ERDC's Forest Ecosystem Dynamics team. Nathan, thanks for joining us today.
Thank you, Chris. I'm happy to be here.
Yeah, absolutely. Let's, I guess, really start at a high level. Talk about why is this needed?
So for this project, we are working in a military direct research program called the Intelligent Environmental Battlespace Awareness, or IEBA. In that program, it's multifaceted. There's a lot of teams that are working on looking at soils, hydrology, Arctic environments, extreme weather events, and even wildfire risk. Within that program, we're focused on the vegetation, and our team is working as part of the Forest Ecosystem Dynamics team. We're working on modeling forest, but we also have a rangeland task that's being led by Dr. Ryan Busby at the Construction Engineering Research Laboratory in Champaign, Illinois, so one of our sister labs here at ERDC. So our team is looking at vegetation as a whole, but today we're going to be talking about the Global Forest Modeling Toolkit that we've worked on to date.
Sure. So talk about what it is. What is the Global Forest Modeling Toolkit?
Yeah, so what we're trying to do across IEBA in general is provide military planners working in their operational environment information that is pertaining to how we assess the environment. So what are the things that would inform a decision-making process? So the Army has what's called the MDMP, the Military Decision-Making Process, and also another acronym called IPB, the Intelligence Preparation of the Battlefield. And within those kind of rule sets of how decisions are made by tactical commanders, what we need, there are these things called geospatial decision aids or tactical decision aids that require vegetation input. So for example, if you are doing a cross-country mobility analysis, you need to know information about vegetation, particularly if you're moving through a forested area. You need to know the stem spacing, you need to know the diameter or the size of those trees that you're maneuvering within to have an understanding of whether or not that vehicle is passable within that environment. The problem that we're running into is if we look at this at a global scale, vegetation is really today available at what's called like a land cover classification. You can look at this part of the world and see that it's a forest, or you can see that it's an agricultural setting, or that it's a body of water or a wetland habitat. But if you zoom into that forest, there's not any information there that tells you about that spacing or the diameter of those trees. And so what our IEBA vegetation task and our Global Forest Modeling Toolkit is aimed at is providing a mechanism at which we can make predictions at a global scale to inform information about that forest. And so we want to be able to look at the canopy cover, so how much density of overstory vegetation there is. We want to look at the tree diameter. We want to look at the number of stems per unit area, how much density or how much basal area that stand occupies. And the goal of that is to produce products at a kind of a two-dimensional scale for a specific location in the world that tell you about what that forest is, so that it could aid a military planner or a geospatial analyst tasked with informing a decision moving forward.
Sure. So I guess if I'm understanding right now, traditionally the data that's available, like you said, is nothing more than there's a forest here. And so you're giving a lot more specific data about all the different characteristics. Talk about why that matters. Why does the military need to know what the canopy is and the stem diameter and all those sort of things?
Sure. So with understanding vegetation, I mentioned there's a whole support of warfighting function. There's 6 of them. They're command and control, maneuver and mobility, there's sustainment, there's fires, there's protection, and there's intelligence. And across all of those warfighting functions, there are vegetation inputs required by doctrine. There's over 18 tactical decision aids that require that vegetation input, as I mentioned. And what we're trying to do is today an analyst looks at some place in the world and says, this is a forest, they could look at imagery, could look at infrared imagery and say whether that's a coniferous or an evergreen forest or a deciduous stand, an area that, in the wintertime would not have leaves. And if you're interested in mobility or a line of sight analysis, or you're doing communication planning, having an understanding of what that forest is, both from an evergreen deciduous standpoint, but also understanding what the density of that vegetation is in the canopy versus what's on the ground, is the thing that's currently lacking and that our program's trying to bring value to. So how do we do that? From a global perspective, it's not an easy task. If
Right.
you look at the terrestrial surface of the earth, about 30% of that is land, and another 30% of that land is forest. And so we're looking at a 30-meter map scale, which is 900 meters squared, so 30 by 30 area pixel. If you look at just forest, that's over 44 billion pixels across the surface of the earth. And so we've got a big task, and we have a big team to try to address that. And we're also using the high performance computing center here that's at ITL. And that's where the machine learning and the AI piece of this comes in. We're using very large data sets to try to provide a geotypical representation of what a forest condition would look like anywhere in the world. And to be able to do that, we need to take information from places that we can access data and build a model to make a prediction for places that we can't. So in the Army, we've fought most of our conflicts in the last 30 years in desert environments. An understanding of the forest and the density of vegetation, as we've talked about, has not really been a priority. And we think in the future, having that information at a military planner's tool set and having that capability is really important. And so the goal of our task is to be able to build this model at a global scale. But the hard part is, how do you do that, right? How do you identify other places in the world of what the forest might be? And so what we are doing as part of our team is building information data sets, so explanatory variables that we can access at a global scale. A lot of that is based on satellite derived information. And we're pulling that information into a machine learning algorithm, and a random forest approach is what we're using. And we're trying to predict what those explanatory variables are for other places in the world. So how we do that is we derive these ecological analogs. So we're looking for similar locations in the world that occur somewhere else. So a nice example might be is if I'm working in a maple beech birch forest in northern Michigan, I can find a maple beech birch forest that's occurring in Europe. And why are those forests there and they're both the same? Well, they're at similar latitude, but they're also in similar climate zones. They have similar amounts of precipitation and temperature. They may occur at similar elevations or slope or aspects of that mountain feature. And so what we're trying to do is put all of those variables together into a prediction tool that says you're in a very ecologically analogous region and the forest types are the same. So what can we glean from that to have an understanding of what that condition of that forest is even under the canopy? So not only can we say this is a deciduous forest that's comprised of maple beech birch, but we also know that forest is 80 feet tall. Well, we can go to northern Michigan and look at a maple beech birch forest that's 80 feet tall and measure the trees and gain that information that we need to be able to estimate what the stem diameter is, what the spacing of those individuals are. And so that's really the power of what we're doing, and the revolutionary part of what we're going to provide to a military planner is the level of details for vegetation that they need for those geospatial decision aids that they currently don't have.
Sure. And going back again and you mentioned different warfighter functions, but the ways they can use it. I mean, to even drill down, I mean, it's just, like you said, line of sight communications. They're needing to know how far apart the trees are to which you can see, sensors, whether you can get vehicles through it. I think you even mentioned even things like fire risk, and to know, where you are and what the risk of a fire and so forth. I mean, you talked sure about just some of those specific examples of how knowing these characteristics of the forest can pay off for the Army and the warfighter.
Yep. So vegetation, as I mentioned, has really been a priority, but it is a key feature of terrain. And so there's a lot of acronyms and approaches in doctrine, but military aspects of terrain are looking at how do we make those assessments? How do we look at line of sight? How do we look at cross-country mobility? How do we look at concealment and maneuver within a forest? How do we look at protection from horizontal flat trajectory weapons? How do we look at wildfire risk of an area where we may have troops set up? How do we understand how to stage and put equipment where we need to stay hidden, or we may need to communicate in areas that are open? And so the goal of our 30-meter prediction pixels is to be able to say, not only is this a forest, but if you need to move within that forest from point A to point B, here's the best places you can go to stay hidden. Or if you need to have a two-way radio communication in an area that's got a light understory and a dense canopy, we can tell you where that area is based on the tools that we'll be producing as part of the IBA.
Yeah, sure. And you mentioned earlier, geospecific or geotypical. You said these are geotypical. Can you kind of just talk? I know one important part of this is geospecific versus geotypical.
Yeah.
Explain
Yeah.
the
So
distinction.
So a good example might be in your backyard, you may have two trees, right? You may have one at the fence line and you may have one up in the front by the water bath or a water, yeah, for birds.
Sure.
So water fountains. So a geo-specific scene would be able to map your exact yard and the location of those two trees. We know how tall they are, how big they are, and where they're situated on the ground. For a uh, typical model, we're trying to understand just in general, if we were to make a prediction for your backyard, we would estimate there'd be 2 to 3 trees, right? Versus you have 100 trees in your backyard. So a geotypical model is not the exact placement of those individual stems for a forest, but it does say in this forest, this is the forest you're likely to encounter. This should be how tall they are. This should be how big they are. This is what we expect that spacing to be. And from a global standpoint, that's a big task and really good, but it's also valuable for mobility assessments. If you're trying to work in an autonomous environment and you're trying to create a digital twin to be able to train and test autonomous equipment that you're going to deploy in a real environment, you need to train in those scenarios and see how those sensors will perform under a variety of environmental conditions. And that's the goal of this project, is be able to create these geotypical representations of forest that we can then use to not only inform soldiers going there tomorrow, but we can give that information today of what that's most likely going to look like.
Sure. And I guess another characteristic, another important part of the characteristic of the forest is time of year too. I mean, when you mention canopy cover, I would imagine the traditional maps are the forest, or it's not a forest, but
Yep.
knowing, okay, now it's the middle of November, what is the cover going to look like compared to the middle of April or June or whatever
Yep.
for that specific location?
And seasonality is really important.
Right.
Just like you mentioned, if you're in a coniferous forest or an evergreen stand, you can stay hidden all year long. If you're in a deciduous forest, that's not the case. And what we are trying to do from our global model is what we've ran into is, right, seasons change depending on where you are. And so we even have a method at which we're trying to calculate kind of the peak seasonality across the globe, so that we can say anywhere in the world, if you're at a 60% evergreen forest and 40% deciduous, we can tell you where those trees are located and the amount of deciduousness, or how much of those, what proportion of those trees are going to be losing their leaves. So we are certainly looking at seasonality as a very important feature.
Talk more about just maybe the challenges of getting this data into a format that's usable by the warfighter.
Sure. Yeah. So I'm a forester through and through and civilian through and through, but we're doing a work that's, feeding directly to Army mobility planning and concealment and all these things that a warfighter needs to have. The, the, the challenge with that is we're taking forest metrics, right? So these come from forest inventory methods where we're calculating basal area and density of stems and trees per acre and average diameter, and to a geospatial analyst or a soldier that may not be that relevant or informative. So one of the tasks in our IBA program is to be able to not only codify that information, model and predict it with accuracy, and have a good dependency on what we think we're predicting these conditions to be somewhere else in the world, but we also want to be able to put that into a format for that user to be able to use. And whether we're talking about RF propagation in forest, or we're looking at a line of sight analysis, or we're looking at a mobility corridor for certain, equipment, let's say a Humvee to move through, there are parameters that that vehicle has to be able to turn and maneuver within that forest that may be very different than the radio frequency communication planning team may need. And so a large task of what we're doing is not only predicting these outputs, but then being able to bend those into units or metrics that those end users can use.
Environmental sensing, I think, is another big piece of this. You talk about how this supports environmental sensing.
Yeah, so we also partner with another laboratory here at ERDC Vicksburg, the Geotechnical and Structures Laboratory, or GSL. We work with their mobility systems branch quite often in the autonomous world. So the GVSC, the Ground Vehicle Support Center, sits at Camp Grayling, Michigan, and the GSL mobility team does a lot of work with them to look at how autonomous tanks and all kinds of Army robotics work in a terrestrial environment. If you are used to autonomous equipment, they all run on sensors, right? They've got cameras and thermal and LiDAR and all of this information that it's reading to make a decision. And the GSL mobility team is always working to make that decision quicker, faster, better. The reality is you throw a sensor in an environment that's forested and it doesn't know the difference between a tree and a patch of grass, and it doesn't know whether it should override that vegetation or it should run into that tree and not be able to move. And so a lot of work is done by that GSL mobility team to create a digital twin or a virtual environment that when they are running those scenarios at the GVSC, they can come back and then run that same sensor through a whole series of tests. And we go and collect the vegetation data to help create those geotypical scenes, but to also provide the environmental sensing needs that it has to understand what is vegetation, where should you expect the height of the leaves on that tree to be, so that you know whether or not a vehicle can move through there or the antenna platform that's on that vehicle can navigate through that forest. So a lot of what we're trying to do in our IBA vegetation task is provide outputs that go to those communication planners, but can also feed into data that's needed for our digital twin creators and that GSL mobility team that's looking at autonomous features.
Sure. So, and kind of building on that, so obviously you're working closely with the autonomous mobility team at GSL. Just talk about how this effort is working with other ERDC laboratories and some of the other collaborations. I know you talked about the work with Several at the top and
Yep.
some of the vegetation models there.
Sure. So we work with our Coal Regions Laboratory in Hanover, looking at the Arctic task. That's part of our larger IBA effort. The GRL, the Geospatial Research Laboratory in Alexandria, Virginia, that's our integration task. So a big push of what we want to do across soils and vegetation and hydrology is put that into a geospatial, a Warfighter geospatial data model. And so the goal of that is to be able to codify all this information into user inputs that can then be readily used by the force. But to do that, it has to go into a data model that can be digested and pulled from. And that creates that common operating picture in place for a data repository of the information that we're providing. So as we derive these metrics and build these tool sets that assess vegetation and predict what forest conditions are, a large task for the integration team is putting that all into one place so that they have this stack of information for vegetation and soils and hydrology that can feed into what they call a modified combined optical overlay, a MCOO, to be able to hand to a tactical commander that's got to make a decision in an operational environment that has that information in front of them to make the best and wise use decision with that information.
Yeah, sure. I guess backing up a little bit, talking about all the uses of this and, how can the Army use this data? I know we've covered a lot of it. Have we kind of covered all of that? Before I kind of move on to something else, I want to make sure. I know there's several different areas we want to talk about on there.
Yeah, from the Army's standpoint of use today, we've recently done several engagements this summer. One was a trip to Poland, working with the Military University of Technology. They do a lot of work there called passability, but it's essentially our mobility assessments where they look at mobility corridors in operational environments. And they have very similar approaches and strategies as we do, being NATO allies. They look at their cross-country mobility assessments very similar to us. And so we went to the Suwałki Gap with that team in Warsaw, Poland, and collected data and force metrics to not only validate some of our global predictions that we're doing for Poland, but to look at how they are assessing vegetation. What are the requirements that they have? What are the needs that they have? And where are the data gaps that they have? And surprisingly, it's all kind of the same. They are stuck with the same task of here's a forest, but we don't know a whole lot about it. We need data to inform that decision making. Another task we did this summer was to go to Fort Polk, Louisiana, and that's where the JRTC, the Joint Readiness Training Center, exists. and they have a large training area called the box. And so one of the things we did with their Intel team at the JRTC was to come and show our model prediction for what we have done there at the JRTC. We collected field data with their Intel team to show them how we collect that data on the ground, how the model output and the metrics that we produce could be used. And we have already loaded that information onto their GeoPortal for their JRTC units to use, practicing unscripted, deployment opportunities. So we're really excited about that task, and that gives us a really important touch point to Army end users that could see the validity of this data and be able to assess how they use it in an operational capacity. And then the last thing we did this summer was to go to the Joint Base McGuire-Dix Lakehurst. So it's called JBMDL.
In New Jersey.
And that's in New Jersey. And that's where they do a lot of the communication testing and assessment and analysis. And the same story is there, right? They're doing communication planning through forest. They do them in wintertime and summertime operations, just as you mentioned, that importance versus when the leaves are on the trees. And we worked with, for that effort, was really exciting. We worked with all four service academies. So we had cadets and midshipmen from the Coast Guard and the Navy and the Air Force and the Army, and they went and helped us collect data. And these are tomorrow's future leaders understanding kind of what the value of our product is, how we are collecting that data, how we're building that model capacity, and what the purpose of that end user is, particularly at JBMDL for doing communication planning. And so we're looking at RF propagation in forest, and our GSL mobility team, the partners that we work with on several things, they've even created a virtual environment for those two sites that we test for communication planning with the cadets. And so kind of the next phase of this project, where we're currently at a 2D map that says, here's the forest and here's the metrics that are assigned to that. The goal is to then grow that forest, pun intended, into kind of a Minecraft forest. We want to be able to create voxels that describe where is the vegetation in the canopy versus the stem of that tree, and how do we provide data to estimate what the area that these stems and vegetation represent across large scales. And from a communication planning, whether you're looking at horizontal or an angled shot, and you need to have an understanding of what that density of vegetation is the goal is to be able to provide that vertical stratification of not only this is the metrics that are there and this is how dense that forest is, but this is where you can expect that density to occur in a given stand.
Yeah, sure. All these different engagements you've talked about between going to Poland and going when you're in New Jersey and so forth, working with the warfighters, and what are some of the things that you've learned from these collaborations and learned from the engagements with them?
The biggest thing we've learned is just the need for this level of information. As I mentioned, there's so many of these geospatial decision aids that require vegetation inputs. They need to know canopy cover, they need to know stem diameter, they need to know the spacing of those stems, and even in a very geotypical standpoint. And that data today, from a global perspective, really just doesn't exist. If we look at the continental U.S. and we say, hey, we want to know at Fort Polk what the trees look like, we go measure those trees, and it's very easy. But what challenge we're faced in this global project is we may be trying to predict vegetation metrics or forest condition in places that we can't access. So in the Army lingo, they call those A2AD sites, so anti-access area denial. These are places we can't just go measure those trees. We can't just go fly a drone and collect imagery to make some assessments of what that vegetation condition is. And so part of our IBA task and the value of it is that we're going to be able to do this anywhere in the world. And we're going to be able to do that at a resolution that we think is very informative and helpful for a military planner looking at an operation or a corridor that they want to do a particular exercise or put troops on the ground for. And the capacity of us to build that predictive capability today to inform a decision tomorrow, we think is really, really unique and going to be valuable.
Yeah, and as you said, partnerships with other countries is a big part of this. Again, the engagement in Poland, but talk about those partnerships and the value it brings.
Yep. So a lot of the data that we stand on the shoulder of giants from the standpoint of how we're doing this model work at a global scale. The U.S. Forest Service has a forest inventory and analysis program, and we're working very closely with them to emulate the same methods that they developed to model forests in the U.S. The Forest Inventory and Analysis Program in the lower 48 has one permanent plot every 6,000 acres. So they have a ton of data, hundreds of thousands of plots that they inventory almost on a yearly cycle, where they get plot level data that look at species assemblages, how big the trees are, how tall they are, all the things that we're trying to do. And they have developed this random forest algorithm to be able to look at and provide a very supervised classification schema to predict forest metrics in other places. And so where they take this approach to take their permanent plots for a given state. So I mentioned Michigan earlier. Their permanent plots in Michigan. They take that data and they model what the forest types are across the entire state of Michigan using that plot level data. So we're doing that for the world, but we're going to be using the FIA data in the US. We're going to be using the FIA data in Canada, and we're going to be using the FIA data, a very similar approach that's in Mexico. And so we have to date built kind of a data repository of information from all of North America, which spans quite a latitude, right, all the way from boreal to tropical environments, and gives us kind of the baseline at which we can build and grow this model to predict in places that occur elsewhere, and particularly these A2AD sites. But as part of this project, the goal is that we'll work with partners like Poland and other countries to be able to ingest their data and provide model outputs for their respective countries to inform their own military planning and use case. So that's really the goal of this project, is to take these foundational approaches that the Forest Service has done at looking at things in the United States and bring in larger data sets, bigger high performance computing systems, and be able to bring in some of the AI and machine learning capabilities that we have to then build this global capacity to estimate vegetation anywhere on the earth.
Yeah, and on that line again, talking about when you were pulling, you mentioned you went to the Slovakia Gap and we're out there doing some sampling, and what you saw is it was pretty validated a lot of the work you've done.
Yeah, that was a really cool trip from the standpoint of, seeing on the ground what our model is going to be predicting in other places. So I'd never been to Poland. Our model had never been to Poland. We weren't using any data from Poland, and we were taking our model and predicting what the forest type were. And they were very different species, right? But what we found is that even at a 30-meter pixel, we could stand in a forest block that may have 3 different types of vegetation, one being an evergreen pine stand, one being a pine hardwood mix, and one being kind of a lowland area full of hardwood trees or deciduous trees. And our model nailed that. We had that 30-meter line drawing these stand boundaries and estimating the metrics for those that we were then able to validate from that data collection effort. So this was a really powerful engagement for us, just to kind of check the box of we can do this and we have that capability. But we're also there with our NATO partners and Polish officers that were seeing what our model was doing on the ground in their own forest. And so they're excited to be working with us. They're excited for the data that we can give to them that can inform their passability efforts that they're working on at the Military University of Technology. And so we're excited to see that.
Yeah, that's great. Are there other collaborators that you're working with as part of this effort too?
Yeah, so we work with a whole lot of teams on kind of the Army side, right? We're trying to transition this to Army use cases. So we work with proponents that there's a lot of acronyms with the C5ISR team. We're working with DevCom. We're working with all of our ERDC laboratories, but we're also working with a lot of university partners. So at Purdue University, we currently have an engagement with them looking at global modeling. So Dr. Jingjing Liang runs the FAC AI, which is the Forest and Advanced Computing and Artificial Intelligence Center. And so he has done some phenomenal work looking at kind of global modeling, similar approaches to what we're doing using different data sets and different AI methods. But he has been a very valuable partner with just stepping into this world of how do we estimate forest at a global scale. And so that partnership's been very valuable. And he's looking at kind of how do we refine variables, how do we collect data that's going to be used for that. And so we're using a lot of his earlier trials and success stories to kind of build our own.
Sure. What are there other things I haven't covered, before as we kind of get closer to wrapping up? Anything else that points you want to make that we didn't get into yet?
Not really. The take home of this is that current methods today don't give us, being the military, the tools that they need to make decisions. There is doctrine that requires these tactical decision aids and geospatial decision aids that require vegetation. And to date, that method has not been codified in any process that's really useful and helpful and into kind of a toolkit that a geospatial analyst could use. And so the big kind of merit of what we're doing and the effort that we're putting forward is to be able to build a process that's going to provide that capability to provide those vegetation metrics that are needed to look at military aspects of terrain that are going to inform those decision makers and tactical commanders to be able to make a decision in an operational environment that one day could and would and should save a soldier's life. And that's really where we're hanging our happiness on and gratitude for this project and the capability that we're hoping to give military planners in the future.
Yeah, sure. Knowledge is power. And obviously, the more knowledge, the more knowledge they can have, the more prepared, and so many different warfighter functions, as you mentioned.
Yeah.
That's great. Cool. Thanks, Nathan. Thanks for joining us today. That's all we have for today. Thanks again for joining us on the Power of ERDC podcast. Remember, there's a live video of this. For those who are only listening to the audio, there's a live video on ERDC's LinkedIn page or on our website, poweroferdcpodcast.org, which also has more resources. And we will see you next time.